So I will actually the quadratic formula, you have to have the formula. So if the key is you have to have it in this format, in the general form. Okay? I will make a little note here. Clean up to see this, okay? Like you may have to do some cleaning up to get that. Okay? Actually, I will get rid of the y equals. The y, I will just cross that out like this. It is 0, okay? What are we doing when we're using the quadratic formula? What are we doing? What are we finding? Those of you that did it. We're finding the x-intercepts. Yes. It's an algebraic way to find the x-intercepts without the calculator. I mean, you still use the calculator to compute, but you wouldn't need a graphing calculator to do this, okay? So in pre-cal, if they can't factor, they will use this, right, to find the x-intercepts. So once you have this, okay, then you use this formula. So we go negative whatever b is, plus or minus, and everything that gets substituted I put in brackets. This is not the formula that you would find if you look it up online. There would be no brackets. But every time, guys, when you have a formula and there are letters, put them in brackets. See them as, okay, there's this letter in a bracket, so I have to insert it into that bracket, whatever number I'm given, right, when I substitute. Minus 4 times A times C. Okay, so this part right here has a special name. In a bit, I'll tell you what that is. Once you are done computing everything up top, okay, you divide everything by 2 times A. And you got to make sure this line goes from, like, it really goes from start to end. Like it makes sure it spans the whole, whatever you have on top, it just goes from end to end like this. Okay. This is called the discriminant. If it's positive, if whatever you get in there is positive, you've got 2 x-intercepts. You're guaranteed to have 2 x-intercepts. If it is 0, you've got 1 x-intercept. If it is negative, no x-intercept, or 0. And so that's important to know. If you do this, if you plug in numbers and you get a negative inside this root, you know you're not going to have x-intercepts. This will never cross the x-axis. You can confirm this with your graphing calculator. Okay, so that the whatever you get inside the root is called the discriminant, and it tells us how many x-intercepts there are. And I will make a little note here that roots is the same thing as x-intercepts, is the same thing as solutions. So that all means the same thing. So if I ask you find the roots, find the x-intercepts, find the solutions, and I will say using the quadratic formula, okay, if I say on the test you use the quadratic formula, you can still verify using the graphing calculator, but you must use the quadratic formula in that circumstance. Okay. Why is it so acting up, eh? Oh, because of the yellow background. It doesn't like the yellow background. Yeah, that's when it does the don't. I hope that doesn't affect you. Don't get a seizure or something. All right, so this should take up less room in my opinion, but if you need an example, some of you might need an example right next to it. I'm just gonna steal one from the notes. Yeah, I'll do one where we had to do. So this is count this as your example because I will give you an AC on this. So if you have something like that, is that too small? I'll zoom into that. I'll zoom into that example right there. And you may or may not, if you don't want to have this on your study sheet, that is completely up to you, right? But if you had that, you got to clean it up. You got to have everything on one side. Y is always equal to 0. If you have any y's in there at all, you make that equal to 0. They disappear. Those terms disappear. And then you're left with x, right? So I'll bring this over to this side, and I'll bring that term over to this side. So it's 8x squared minus 3x squared plus 5x. So whatever sign you have on the right side, you change it when you come over to the left side. Don't forget about the plus 7 is equal to 0. That's what you want. You clean it up. That's 5x squared plus 9x plus 7. Did I complete this on the video? Did I do this example on the video? I'm not sure. If I clean it up, so now you know that A is 5, B is 9, C is equal to 7. Oh, this is actually one that has a negative root. Oh well. So you go 9, negative 9, that's what the formula calls for, plus or minus 9 squared. Let me try something here. This is a teachable moment here. I'm going to try something here real quick. Yeah, we're going to make a change. This one, don't copy this yet. This is just, I'm just going to show you real quick what could happen, okay? Don't copy. I'm going to make a change after I'm done here. So you go minus 4 times A, don't copy this, times C, okay? If you do the part that's inside the root, okay, if you just do that part, you go 9 squared. If you want to use brackets, then you don't have to worry about any signs. If a number is negative, make sure you use a negative button as you enter it in there. But I get negative 59 here. So negative 59, that means that this one is not going to have roots. You actually stop there. If you get a negative, you show me that it's a negative, and then you say no roots because the discriminant is negative. You're done. Okay. We're going to make a slight change to have an example that actually has roots. So I'm going to ask you to change. Let me see here real quick. We're going to change this to a negative. We're going to make 8x squared negative. And we're going to make 3x squared here negative as well. Okay, so make sure you follow me here. I'm changing this to a negative and that to a negative, which means the negative 8x is x squared is negative, it stays, but when the negative comes over to this side, it turns positive. Okay, that's important. negative 8x squared plus 3x is negative 5x squared. That means that a is negative. Okay. So these are my new coefficients. We call these coefficients, right? So I have a negative. So that means this stays. I don't have to make any changes. I just have to make changes to this value right here because a is negative 5, okay? So I've got to make that a negative 5. Copy that part. And then I want you to go over 2 times a, which is 2 times negative 5. And I want you all, if you haven't done this yet, I want you to enter this, the part that's in the root, separately. I don't want you to do all of this in one shot. I want you to just do this part. It's important to get the discriminant right. So I'm going to have my calculator right next door here. And I'm going to go 9 squared minus, this is a minus here, right? 4 times negative 5. So I got to type in the negative using a negative button. Times 7. That gives me 221. So the discriminant is positive, right? It's positive, so I know I have 2 x-intercepts, and this is 221. So this is how this cleans up, watch. X equal to negative times 9 is just negative 9, plus or minus root of 221. Cleans up pretty nicely. Divided by 2 times negative 5 is negative 10. And now some of you are wondering what's up with that plus or minus thing here. Why is that? Because we can go negative 9 plus this root to get one of the x-intercepts, negative 9 minus whatever is in the root to get the other x-intercept. So that's what that is saying. So x1 is negative 9 plus root of 221 over negative 10. And x2 is negative 9 minus root of 221 over negative 10. So we'll figure this out. Here I would say it's okay to use your calculator as is. So I would go negative 9 plus second x2, that's where your root is, of 221. I hit enter at this point. There you go. I hit enter at that point, and then I go divide it by negative 10. So my first root is negative 0.59. Okay, that's my first x-intercept. And the second one, watch what I do here. I go copy paste that top. I paste it down, and I change the plus to a minus. Okay, I take it away. Then I divide it by negative 10. So the second root is 2.39. Okay. So you just found both x-intercepts using the quadratic formula. Okay. So technically this is negative 0.590. That's the coordinates of the first one, and 2.390 is the coordinate of the second x-intercept. Okay. So this is today's mini lesson, right, for a quadratic formula. It's longer when you watch the video.